So Mor, I hope you'll have something fun for us in the next 45, 50 minutes.
I hope so too.
Okay. Mor, the floor is yours.
So thanks for inviting me, and thanks for also thank you for making this podium as tall as you possibly could. This helps. I'm going to talk about social media and the way it reflects our world and helps us see it and understand it like it was never possible. So this talk is just one example of things we can do with social media. I'm going to talk a little bit about how it connects and what are the implications for information retrieval. So really this talk is about this picture. How many of you have seen this picture in the last few weeks? So some people here. This was taken in from the first appearance of the new Pope a few weeks ago, last week, in the Vatican. So as you can see, the sea of mobile devices, and NBC News were clever enough to juxtapose this with an image from 2005, the same occasion. So if this image teaches us anything, it shows us the huge impact that Pope Benedict had on the adoption of mobile devices. But perhaps more importantly, it shows us how the level in which we document our world and share, and the level in which we pay attention and share our attention, our collective attention for things that are happening in the real world. So it is a coincidence that the photo on top was taken in 2005, because then we started thinking about exactly these type of collective content and what can we do with it. And to me, 2005 was also the beginning of location-based social media as we know it today. So Flickr introduced geotagging and created an easy way for people to associate content with location at scale, probably for the first time. And almost immediately, we had lots of dots on a map. And those dots on the map were fine, it's nice, but they grew in number. This is, when we started working on this, this is the 5,000 geotagged photos that were available for the San Francisco area on Flickr. But those growths grew in number, and in 2007 there were already 40 million images worldwide. So surely we thought these dots can tell us a little bit more about the world than just where photos were taken. So with my team at Yahoo Research Berkeley, we did some analysis that actually extracted, using those photos and the tags and the text that were associated with them, for every region in the world at any zoom level, going up or down, it shows you the most important and salient features for that zoom level. So I'm not going to show you the full demo now, but this is San Francisco. Some of you may recognize the Golden Gate Bridge and a lot of the features and landmarks you would imagine. And if you zoom in, you start seeing local and more local features, like, for example, the Yoda structure in the park. If you visit San Francisco, make sure you visit Yoda. He'll be happy. So in 2007, and already with 40 million geotagged photos, we could extract a very strong signal about the real world, about people, about their geographic activities and interests, and the things they pay attention to, the things that they tell us are important. So that was great. And then we looked at Paris. And we noticed something funny on the Paris map. Does anyone notice something unusual that you wouldn't expect to see in a Paris map? So the top left, Les Blogs. Anyone knows what that is? It was a conference in 2006 where a lot of bloggers, early bloggers, got together. Obviously took a lot of photos, geotagged them, and showed up in our landmark map as probably looks like the most important thing in Paris, even bigger than the Eiffel Tower, taller than the Eiffel Tower. So, so we thought that we can do a better job modeling, identifying, and exposing those events. So instead of showing a static image of the world, we can show a dynamic view of the world generated by social media. So we asked ourselves, can we actually generate this? Is it a fluke, or can we get more data back then, still in 2007? And we showed in a ECIR paper that we can extract a very reliable signal on, first of all, detecting the places that are important, and second, detecting events that appear in the data. So, by the way, as a side note, this received a resounding score of 3 out of 5 in ECIR 2007 review. Did get in, and now is I think it's the second most cited paper from that conference. But But it also seems that it was, after Tahrir Square and after everything that happened in the last few years in social media, this seems obvious. But it was not the case in 2007, before Facebook got popular, before Twitter got popular, before the iPhone had location, before the iPhone was out, I think. So the iPhone was released and popularized media and location. So now we're dealing with a world where this can happen at scale, everywhere, and on all the time. So, but when we did this, we realized that the actual challenge that we're tackling here is literally organizing the world's memories. And I'll tell you a little bit about what I mean by that, and I'll give you a few examples. So everything that happens is now recorded in social media, as I said, and increasingly and overwhelmingly people share everything. This is from when the New York Giants won the Super Bowl, but any other events, large or small, are a record of our humanity, a record of our communities, of our interests and activities. And those events can be big and small. They can be Tahrir Square or the Radiohead concert or Bring Your Own Big Wheel, a San Francisco event. If you're there in October, I recommend checking it out. And other events, workshops, conferences, everything. So surprisingly, after 7 or 8 years of social media, we're still doing a pretty crappy job at presenting and aggregating the content around these events. Take, for example, the Le Blogs 2006 that I showed you before. If you go on the web, search for some record of the conference, there are a few blog posts, very little to show in an organized way. Don't go so far as 2006. Try to find content for ECIR 2012. Other than titles of papers, you will not see a lot of organized information. And there were hundreds of people in ECIR 2012 that were sharing photos and tweets, and they were saying what they thought about the conference and about the speakers. It's all gone. So we wanted to fix that. Let me just use this Outside Lands Music Festival as a quick example. 40,000 people went. It's a festival in San Francisco. They shared over 20,000 tweets and photos. Stevie Wonder played, Jack White played, Neil Young played. It was a big event. So where is the record of that experience on the web today? Where can we go and see what happened? So let's see. We go to Google. I get 10 dead links. So that most of them were shared before the event. I go to Google Images. Well, I get the sense that some of my favorite web banners had played. But other than that, no record. I don't see Stevie Wonder here. There's very little information about what happened. Let's go to Twitter. They recently had reorganized their search, but still, when I see the top tweets, they're mostly recent information, not about what's going on. And even if I, click back 10,000 times and I get to the information, I will just get a long list of tweets that people shared and not much to understand. So, in short, we're not very impressed. So, this was the project. There's an increasing amount of data. It's fragmented, presented in unuseful ways. Can we fix that? Can we create tools to help you collect and consume this kind of content? This is a project sponsored by these people down here, the NSF, Nokia, Google, and Yahoo. And most of it is in collaboration with Luis Gravano from Columbia University. So there were 3 key technical objectives and challenges that we had to address. Detect content, identify it, and organize and present it. I'm not going to talk about all of them today, but just briefly, detecting events, and I'm giving a few links to papers you can find on my webpage, means that we can detect breaking events in social media and understand their nature. This work, there's some of this work that I see even in the conference here this year. But not only detecting the events, we also want to be able to distinguish between trending topics like Justin Bieber got a haircut to things that are really happening in the world, like there is a fire on 52nd Street. So not just detecting events, but also classifying and understanding their content. So of course, this is a challenge with the scale and the noise and the short format to do this in real time with high recon, high precision. Then we want to identify relevant content for those events, whether it's real time on hindsight or in hindsight. And we want to highlight the most important content. That's another set of challenges. We want to do it for planned events, for unplanned events. We want to go beyond just the hashtag or the location and the time. And I'll talk a little bit about one work in which we attempted to do that. And finally, we want to organize that data. So all the data for the event, hundreds, thousands, tens of thousands of posts, you want to present it in a way that makes sense to help people effectively explore, experience, and analyze that data. And you want to do it in a way that makes sense for specific user scenarios and tasks. And we did this. I'll show you some work we did for journalists. It can also be work that's aimed at consumers. We did some work to help first responders understand what's going on based on social media data and so forth. Let's see. So out of all of this, I'm going to show you one example of our work to identify content and two examples of how we organize the social media data to help extract the narrative and extract the story of what happened. So this will be the overview. The first, I'm going to call it the Multisite work, and then Vox Civitas and Multiplayers are the two systems I'll present. When I'm done with that, I'll show you a little bit how it led into a product that we're trying to put together that brings all of these ideas together, and then I'm going to talk a little bit about how this relates to information retrieval and where I see this possibly going. So let's start with the Multisite work. I really like this work. It was published in Wisdom 2012. And the idea here is addressing the problem of automatically identifying the content that is associated with events. So starting with some event record and finding the content from multiple sites, across sites and services with high recall and precision. So this will address the fragmentation problem that I mentioned before. So we start with the event record on Last.fm or Eventful or on Facebook. There are a lot of sites that allow you to say, this is happening, this is going on. Usually you get some structured information, but not very well annotated. So you get the title that may be long or short. Sometimes on Last.fm you get an artist name. You have a venue and a location and longer descriptions, perhaps keywords. So from that, we're going to start with that. We're going to go to Twitter, YouTube, Flickr to get relevant content. And we want to create a richer event presentation that's based on the content that was shared. But of course, there are challenges. Turns out it's not easy. The descriptors are not well formed. They're usually pretty crappy. If you just want to apply IR to the fields as they're posted by the user, it doesn't really work. And then on the other hand, the content is not very well formed. It's short format, few tags or few words, sometimes famously less than 140 characters. There are formats and conventions that are different between different sites. Some sites do have time metadata, some don't. Some use a hashtag, some don't. So it's the ecosystem is not very organized. And obviously, there's a lot of noise and differences between the services. So what did we do? We took a two-step approach where we formulated queries. At the first step, precision-based queries. So we issued queries that we thought will give us high precision content. And in the second step, we issued queries that will allow us to get broader content using what we got from the results that we got from the precision queries. And then, this is the neat part, we validate the queries based on what we know about the event and what we know about the event model that we expect, and I'll explain. Here, for example, this is step one. We look at the event description and we perform, actually we experimented with a few types of term extraction techniques to get the high precision content. So content that is almost certainly associated with the event. So from the event record, we go to a query like Andrew Bird, Opening Gala, Celebrate Brooklyn, and Prospect Park. So in the paper, we obviously give all the details about how we do the term extraction, and we played with various methods to do that and various ways to combine these into a query. And by the way, high precision, we didn't do it in the paper, but high precision may also mean looking at things like the hashtag, which usually, for example, for ECIR 2013, will give us high precision results for the conference, or looking at the exact place and time. So there, if the content is geotagged. So there are various ways to get high precision content. Now, when we do that, then from the event record, we now have kind of a small set of content items that we know are associated, or with high degree of certainty are associated with the event. Then the next step, what we do in step 2 is we use that corpus of content items to generate more general queries to improve the recall. So what we do here, again, we're using term extraction. We use some classic IR methods like TF-IDF, look at frequency. We look at identifying known entities. So we generate we generate queries that will help us improve the recall. So for example, from the Andrew Bird concert, we may extract Andrew Bird and State Farm Insurance as 2 possible queries that appeared in the content. That gives us, a system that works across different sites. Will work better with short content because we're now not issuing longer queries. But of course, we'll introduce noise and a potentially large set of queries and results. So we cast our net here very wide. In order to control for that, and this is the part where we looked at post-filtering based on the event model. So the nice thing about events is that we know what to expect. We know what time, how the time distribution for the event content, what time its distribution is expected. We know the location distribution. We even know or can estimate the topic distribution. So if we get a query where the result set doesn't match the model that we expect, we can then discard that query and use queries that match the model as we know it. So for example, so we want to go from a large, let's use all the queries and all the content, to find the right queries that give us a model or match the model that we might expect. So here's an example for just the time-based modeling, the same 2 queries that I mentioned before, Andrew Bird concert and State Farm Insurance. We can see that State Farm, if we issue that query, it just gives us the same number of results every day, every day in our query, while the Andrew Bird query just gives us results that are highly concentrated around the event time. So that's what I mean by matching the event model. So now we can discard the results of State Farm Insurance query and keep the Andrew Bird results in the data. So I know you people love a good evaluation, but I'm going to spare you the details for this talk. There are some beautiful figures in the paper, so you can refer to those and see what we did. But very briefly, we used human judges to both rate the queries that were generated according to their match to the event, and rate the content items according to their relevance to the event. And we talked about how different strategies performed according to each. But the takeaway, for us, it was really exciting. We could start extracting this real-world information from multiple sites without depending on a hashtag or some metadata that's specifically associated with the event, and get high-quality results. So I'll get back to that later to show you a little bit more. Let me move on to talk about 2 systems where we started to organize and present social media once we got the content in, to present it in a more consumable fashion. And these systems were designed not so much to solve a technical problem, but actually, and even not so much to solve a user problem, but just to start exploring the user problems that exist around events. So the 2 tools, one was the Voxivitas one was geared to help journalists, actually, and the multiplayer was more consumer-based. Voxivitas was about Twitter, and about the fact that even in 2009, when we started this work, it was clear that Twitter gives us the public's reaction to anything that happens. Unfortunately, this reaction is, in many cases, completely unintelligible. So here we're looking at some of the responses around the Golden Globes. You know, some of the tweets are more interesting than others, but obviously there are hundreds of thousands of posts that people make about the Golden Globe. And we were interested to know, how can a journalist make sense of that content? Whether Twitter can help a journalist to look at the Twitter content that's contributed around the large-scale broadcast event and make a story out of it. Understand what the public response was and reason about the public response in interesting ways. So we wanted to know what kind of insight we can provide with such a visual analytics tool that can help them do their work. Or in other words, what would a journalist ask of Twitter? So we came up with a few hypotheses of what they would do based on theories of media and journalism. And we tested a number of ways for them to direct attention to things that might matter to them. So for example, and we can read the paper to see how we computed that, but again, we're using very straightforward IR tools for this work. So we look at relevance, how relevant the tweet was to, for example, a transcript of an event. We look at uniqueness and novelty, so how interesting or different something that was said in a tweet was. We look at sentiment, which in my opinion still doesn't work on the web, and everybody who's telling you differently is telling you something. But we try to explore at least if journalists will find value in extracting sentiment. And we looked at keyword extraction to start to understand, to reflect to the journalist what was going on in the transcript. So let me show you how this was used. So this is a joint work with my postdoc, Nick Diakopoulos. So Nick put together this interface, which is really, it's not a visualization, it's a visual analytics for professional interface. So we see, one simple thing you can see here is the volume of tweets over time. The one interesting thing, I think this is the State of the Union in 2010, and we had 100,000 tweets. That was pretty much, it was close to the full data set then, only 3 years ago. And this year, if you look at the debates and the activity around media events like that on Twitter, you have about 100,000 tweets per minute. We had 100,000 tweets for the 90 minutes that this lasted. So we see tweet volume over time. We see the general sentiment, and I'll show you a live demo in a second. We extracted keywords that were salient at any point of time from the Twitter response to the event. And we have a bunch of other filters. Let me actually show you that are, drag this to the right screen. A bunch of other filters that help you explore, helps a journalist explore the content. So first of all, I can, well, I think this still plays. Let's see. Maybe I can get Obama to say something. Maybe not. I think I'm connected. So in any case, this provides kind of an index, almost an index to the video. So when I click on this, the video will scan, and the tweets will scan to that moment in the speech. So I can see the moment, I can see what people said during that moment in the speech. And I can also click on keywords that we extracted, like infrastructure. This will filter the tweets to show only those that had to do with infrastructure. So I can see that something happened here. He mentioned infrastructure. There are a couple of quotes. I can immediately see the context of why people thought that this was salient, or why people thought this was interesting, and how they responded to it. So this, I guess, is a quote from what he said, put Americans to work today building the infrastructure of tomorrow. So it starts to show us how the things that Obama said in the speech resonate within the population, and how the population, the people of Twitter at least, respond to that work. Delay, another word that shows up, actually in two places. Let's see, here and here. So he says delay popped up because he said something that he wants a jobs bill put on his desk without delay. And again, that's something that a lot of people picked up on. There are other filters. I can filter for quotes, or filter for retweets, or things that were shared with links, or even try with sentiment, positive or negative, and so forth. But what this did is more than, here's my cursor. more than testing the technical features, it allows us to go to journalists and say, hey, this is what we can do. Does this make sense for you? What else do we need to get done? And we explored this with them using mostly qualitative evaluation. So just a few words about the evaluation of both of these, this system and the next one I'm going to show you. We did quantitative work to directly evaluate the output of the algorithms. So we took the algorithms, we had various ways that we evaluated the content using coders or using whatever estimates of relevance that we can come up with. So we did that. But we also did, for both these systems, an extensive evaluation of the users' interactions of the systems and with the systems and what they can extract from it. So this was important for us because we didn't just, the set of tasks was not obvious, and it was not obvious that we got the right set of tasks. So we put together the interface, we let people interact with it, and we extracted from the interaction and from talking to them further inputs and further ideas for the design of the systems. We know what worked, what didn't work, and what they might need further. So in this case, we had about 18 participants that had training in journalism, that interacted with the systems, and that we talked to or interacted with after they used the interface. And we set it up as a specific scenario for them. We showed them the interface and we said, you have, I forget what it was, 10, 20 minutes to write a story and to extract 2 story angles from this data. And then we talked to them and we saw how effective it was for generating story ideas, what kind of insight and analysis are supported, and the shortcomings in how the features are used. So I will again refer you to the paper to take, because the takeaways are nuanced for what it gave to journalists. But for us, at least technically, it told us that there is something interesting in that they can look at the event and understand the structure of the content. So what happened inside the event. So go into a resolution that did not exist before and start to understand what happened in different parts of the event. So you can ask me later how extracting different parts of the event is related to TDT tasks in IR, which is somewhat related, but it's not exactly the same. But the exciting thing for us, again, this was early on, that we can not only get the data or detect events, we can also start to understand in detail what happened during the different parts of an event, even a short one like the State of the Union. So the next project, we looked at a different kind of data. We looked at YouTube data. And that was also a question that was directed at consumers. And that started from a technical idea and a research question that basically followed on behavior of people that we started to increasingly notice at events. And the behavior was people putting their camera above their heads like this. So this was our research question. What are they doing? Why are they doing it? And how can we make sense of that? And for the what and why parts, we did an exploratory, again, interview study where we actually, we went to concerts. It was hard work. We went to concert. We interviewed people that put their hand up. We talked to them about what they do with the content, how they share it, why they share it. This was published in New Media and Society. So I'm particularly proud of this work because we published one paper in New Media and Society, a completely humanities, social science journal, and one paper on the same topic in IEEE Multimedia and in www. So the paper in New Media and Society talked about the motivations and the practices around this. But the other paper asked whether the resultant experience is broken and how can we fix it. So is it broken? Let's go back to Outside Lands. And I said that Stevie Wonder played. So I typed into YouTube, Stevie Wonder, Outside Lands. And here's what I got. One page of results, another page of results, another page of results. And I got, there are still, 7 more pages to click through. And so what's the problem? I'll just watch all of them. So it's probably not a great idea. There are many repeating moments. Some are not relevant. Some are bad quality. Some are not interesting. And the question that we ask is, can we actually improve this experience of consuming this kind of video content? In other words, we were not impressed. So what did we do? Our analysis in this case tried to extract the signal from people's attention. So basically, like everything they do, like they did in the Pope's new appearance, and like they do in the concerts on YouTube, people show us that they pay attention to something by putting their phones up or the cameras up, recording, and not only that, but also sharing that on YouTube or on Facebook or wherever after that. So we want to extract that signal of people's attention by finding overlapping moments where a lot of people record, and then by finding those scenes that are more important and extracting the descriptors to help expose what's in them. And this was all enabled by a technical idea that's called audio fingerprinting. How many people here know Shazam or SoundHound? So Shazam is the app that lets you, if you're at the bar or coffee shop and you hear some cool music and you start Shazam, and it records about 10 seconds of the content, sends it to the server, and it IDs the song. It tells you what song you're listening to based on comparing that song to a known database of songs, of tracks that they have. So, and this is done by a process called audio fingerprinting, where they look at the frequency peaks. I'm not going to go into the details, but they create hash codes that are based on the distance between nearby frequency peaks. So every song generates a long list of audio fingerprints, and if there are enough matches between two recordings, or a source recording and a noisy recording at the bar, they say this is the song that you're listening to. What we did was a little different. We didn't have a clean recording. We had a lot of users recording the same audio source, but they all had some kind of a noisy recording. But what we had to do is to pairwise compare. You don't always have to do it pairwise. There are more efficient ways to do that. But compare the landmarks or the hashes that were extracted from all the tracks to find those tracks that are overlapping, that record the same moment. So in other words, we find the alignments of two clips that tells us exactly that one of them started 18 seconds after the other. But from two clips, if we do that for all the clips in our database, we can actually start to understand how all the clips relate to each other. So we can have now scenes that are constructed, and if this is a timeline, then there is one user that recorded a whole, maybe 10-minute video in this case, and then you can see that probably there was something that happened here because two people stopped recording, and then others started recording. And actually, if you look at the data, this was exactly a breakpoint between two songs. So clearly, some people said, oh, we had enough, we recorded one song, and then others just started recording the next one. So we started to understand the scene structure and what's going on. Once we do that, we can actually even do a little more. We can look at the text that is associated with each of these clusters and extract the terms that can help us describe each of them. So in this case, maybe it was a Stevie Wonder concert, so Higher Ground and Anchor pop up here, and Happy Birthday song pops up there. The idea is that even we cannot trust one piece of content and its metadata, but when we aggregate the pieces of content, when we have 4, 5, or 6 clips together in a scene, we can start understanding and trusting the metadata that is associated with those scenes. So turns out not only you can extract those keywords using the same method. Obviously, you can find the most popular moments, because that's when everybody puts their cameras out, and I'll show you in a second when that happens. You can find the best quality audio by looking at the audio fingerprints and modeling the matches between the different clips in a scene. And you can, most importantly, play back in a concise way. So you can play it back, instead of playing one track after the other, you can play all the clips at the same time in a synchronized video player. Actually, let me show you how this looks in a second, but just one note. when we do that, when we extract all this information, suddenly we have a system that has very little redundancy. So you see everything you want to see in one shot. It's more relevant because we're showing you the important content first. We know what the important scenes are. And it actually improves as content is added. So on YouTube, if somebody uploads another Stevie Wonder video, it's added to the end of the list. In our system, if somebody adds another Stevie Wonder video, they actually show us their attention, and we model their attention, and we say, oh, this is another video for this scene, or this means that this is more important than the other. Actually, let's see the video, and I think let's see, sound is on. So the player is. This is a demo, and the player is a little broken, but you'll see in a second how this works. So this is the timeline. These are all the videos that were captured and synchronized by time. From this scene, this is MGMT. How many people here know MGMT, the band? I think a lot of you will recognize this track, even if you don't remember the band name. So the one thing you can look at, the one thing you can see is pretty much clear when they start singing, right? So everybody can see that. We'll see in a second. So when they do that, well, he's up with the Chilean flag, so everybody's happy. But when they actually start the track, people are just, oh my God, we have to capture this. So what you see on top here is the thumbnail. This is actually the part that's broken, but the thumbnail should be playing on top with the other videos. But I can also, they're not showing on top, but I can switch to get the different views. So how many people recognize the song? More than So people were pretty happy. And if we step back, I don't have it right now. If we step back and look at the entire event, that this song, which is the biggest hit, got 8 or 9 concurrent videos recorded, and other parts of the event were not as popular. So we know what was important. People told us what was important from in the data. So this is not actually just for concerts. Here's another event that in the US got a lot of headlines. I don't know how many headlines it had in Europe or here. But this was a famous pepper spray event at the University of California, Davis, where there were protesters, and one of the policemen pepper sprayed relatively peaceful protesters. And the interesting thing about that, and the reason social media is so important, is that the media, the real media, was not there yet. Nobody was there recording this event with TV cameras. But look at how many photos, how many cameras show up in the frame. Actually, the one other interesting point, when this video starts, this user uploaded the entire 15 minutes of the event to YouTube, and he actually annotated it and said, skip to 4 or 5 when the shit hits the fans, right? But what you can actually see in the data, that once we align this content, you know that this is where the most important things are going on. So I can jump directly here. Where did we go? Here. So soon you'll start, you'll see the policeman starts shaking his can. Maybe from another angle.
Children! Don't shoot your children! Here, who wants a sky?
So there's so many people recording. There's actually even more content that we couldn't sync up here. So he's starting shaking his can, and I'm going to stop it right here because it's really painful to watch when he actually pepper sprays them. But this was a significant and meaningful event that was only captured by the crowd and could be amplified when you look at the data and when you have this picture of this data. So back to the slide. So we were interested here I'm still not sure that the multi-view or the playing multiple videos at the same time is the right user experience. But in our evaluation here, we obviously did the qualitative part where we looked at how good the matches are and how good the keyword that were extracted were and so forth. But in the qualitative part, we actually explored whether we have the right tasks or not, whether the users want to see it in a multiplayer or not. And the few cues that we got back from the users is that it's still unclear. They felt more like they're there when they had the multiple views, so they can feel, they can relate to the event. And there might be more work that can be done to see if this is actually psychologically true, if they relate more to content when they see it that way. But they definitely felt like they know what it's like to be there when they had the multiple angles. They definitely understood the level of interest indicators, so that more popular scenes are more important in some ways. But they also wanted to take control. Instead of looking at the videos at the same time, they wanted to make an edit and say, oh, I want to watch this now, and this now, and this now, and maybe even publish that edit and share it with other people. Of course, and one other thing that we haven't controlled for is the audio quality. You notice when I switched between videos, there was a little lag, but there was also a change in audio quality that was pretty significant for the users. So, and in short, the takeaway for us was that we can create from this data an event presentation that gets better the more content is added, instead of just adding to a long list of content that's already there. So the implications of these technologies that I'm talking about, I think, are very powerful. So let's think about this. We're just in the early days of social media, but it gets very interesting when we start to imagine, looking back, what if we had social media, for example, back when the President Kennedy was shot, or when something I relate to personally, when Wilt Chamberlain scored 100 points in the basketball game. Right? It was 50 years ago. It was barely documented, even in pictures. But what if we had people there tweeting and sharing photos and sharing their impressions? And what if we could go back to that moment? Or maybe to Jimi Hendrix's first ever show and see the videos and the tweets that were posted during that show. So all of these will be possible in the future that we're creating right now from the archive that we're making right now. So we started to think about how to put this together in a product that can archive, persist, and reflect on those events as they're going, and also in retrospect. So if you remember the problem we started with, there's a music festival. There's nowhere on the web to see what happened. Here, we take some of the takeaways. We can bring together content from multiple sites, that we can organize the content and expose a story, and then we can create the presentation that scales with the content and try to put it together in a product. So let me show you just a couple of examples. Where is my cursor? So this is Outside Lands. This is just a demo that I'll show you. This Outside Lands Music Festival. So if you just collect all the items, that's great. There are 20,000 of these, so a very long scroll. Right. So it's kind of interesting. There's no place on the web to actually even see this archive right now. So that's something. But instead, we take all this and summarize it using, again, very similar tool to the ones I talked about before, but also some language and some IR techniques. And suddenly, you see the highlights coming out of the content. So you start to understand the story of this event and what happened. So it's the first morning of the festival. People got excited. Then actually, the first show, 10 lines played. And then Reggie Watts came on. Reggie Watts, people know of Reggie Watts? Is it? I'm just showing you obscure American bands now. All right. But what we do here, so we started, when we collect this data here, we started with a hashtag. So we started with the precise queries. But when we do that, we now create not only event level, but even highlight level, temporal, and topical models. So now we can use this information and go beyond the hashtag and actually get content from sites like Flickr that do not use the hashtag. So now, if we start to understand the structure, we can improve the content by getting queries from other places as well. So not just Flickr. I think I have another YouTube example here. Yeah, in Jack White, in this case, we got some YouTube content as well. Pop up. It popped up somewhere else. So I can click on the YouTube, and then we bring together the videos, and they're already synchronized, so you can watch that scene, or you can watch the Jack White show in video. So this was great. This starts to create an idea that we can go back to this event and experience it and find and look at the content of people posting. Here's another. This is a more refined view, no longer a demo of what happens. And I thought it would be a nice visual if I can show the New York Fashion Week. So New York Fashion Week, day 6, thousands and thousands of posts. But turns out that you can easily understand the different things that happen. For example, the Oscar de la Renta, Denise Basso, and all the different designers had their shows. And we can easily identify and bring out the most important, most salient topics from each such day. So it works for other conferences. Here is, for example, a New York Tech Meetup. So in this case, it's a small event. There are only 500 tweets or so. It's a big tech event in New York that happens every month. So about 500 tweets, but there's still enough to extract what was important. So I actually stopped going to this event because I know that the day later I can now see the most important things that happened, what I need to know that I missed. So in this case, the big highlight was Dennis from Foursquare gave a talk. And so I can even click in and get more information about what he showed and how people reacted to that. Back to the slides. So I talked a lot about attention, and there are similar ideas that talked about attention that appeared throughout this work when we looked at events in social media. So Google made the web information more usable and presentable because they used the insights of PageRank. And we're trying to make social media more accessible by using what we call attention rank. That's still not formalized in a very formal way, but kind of capture the idea that we can model people's attentions and we can create better representation of the world based on the idea of people's attention. So we still have a ways to go in formalizing and understanding this more robustly and at scale, see how the attention shifts and what it means, see how it interacts with mainstream media, for example, and how it influences actions in the real world. But let me pause for a second and go even higher level. I think social media is a new information era, basically, a new kind of information system that we didn't have before. So a lot of people have drawn comparisons with the printing press and social media. So obviously the printing press enhanced the velocity and of communication and dissemination of information with books and articles. So like I talked about the growth in the number of Flickr images. The printing press grew the same way from 20 million books in the first century to 200 million books in the next century. And it gave us the knowledge archive. Then we had the next step was probably the digital documents and later modern IR that gave us the next revolution in dissemination and storage and archiving of content, and that became the digital archive. The next step was the World Wide Web that of course gave us the network archive that gave us even more opportunities and information. And now it's social media. So social media, I like to call it the experience archive. We're basically, if the printing press moved us from oral history to printed history, then the social media moves us from lived experiences to captured and archived experiences. Our daily experiences are now captured and archived. So in this experience archive, we need new methods. So each era that we had an information system created in a set of technologies to organize, index, and later rank and retrieve this content. So in the printing press, we had page numbers that were invented for books. We had reference books, encyclopedias, indices, libraries, the Dewey system, and so forth. For digital documents, you know very well, we had TF-IDF and BM25 and LSI and all those all those innovations. For the web, we had anchor text and PageRank and Kleinberg's hits algorithms and all those methods that were created around web content. What are the new tools for social media? And I think we don't know the answer to that yet. We don't know what the new methods are, and maybe there is a reason. And the reason, perhaps, that we're early in the history of social media. So in 1948, we had Holstrom show us that the first IR system that retrieved texts that were associated with a subject code. And this ended up, of course, with IR, with something completely different, with a lot more capabilities. But I think we're in the search by subject code stage of social media. And there are basic, there start to appear some interest in some track tasks in social media that are based around recency, topics, and retrieval, and stuff like that. But I argue this is a great first step, but it's probably not where we're going to end up. And it's the same as my work that I presented today in the same category. It's a great first step, but probably not where we're going to end up with social media data. So I think what we need to do next is to better understand the needs and what we can do with this social media information. So what are the new information tasks? What are the new user tasks and models and user needs that are based on this data, based on this archive of humanity? I'd like to see IR explore a little bit more the new applications and the new things that we can do with social media content, and not just in the context of the web. So what about when we have 5 or 10 or 15 years or 50 years of social media data? What kind of task will be possible? What kind of information can we extract from that? And what will be the tools that are needed to understand this information and present it and retrieve it in a better way? So I'm particularly excited about the retrieval in the context of personal information, whether it contributes to how we retrieve public information, or maybe it's just retrieval over personal information streams. Right now, we're recording the world like we've never done before, but we're also recording ourselves like we've never done before, by sharing on Facebook or by sharing from mobile devices, or even capturing our logs from mobile devices. What does it mean when we have 50 years of data of this sort? How can we change the way we use information, the way we retrieve information based on this data? So I think this world will need the IR community to step outside the web and existing tasks and start to explore and analyze what is possible with social media and with this new kind of personal information systems that we've created today. So I hope this community jumps on the wagon and helps us expand this vision to help a world that's reflected in the image that I started with of the Pope. Thank you very much.